Mathematics instructional video. Linear versus nonlinear equations. Of the functions below, which are linear, which are nonlinear? In order for a function to be linear, it must have a constant rate of change. Constant rate of change. Don't let the words confuse you. Constant rate of change means that on a graph, it goes up in a straight line. This graph of w of x represents a linear function. Wx is linear because the line is straight. What about f of x? It's a table. The way to tell is, does f of x have a constant rate of change? From the point x equals 0 to 1, it increases by 2, 3 to 5. From 1 to 2, it increased another 2, 5 to 7. From 2 to 3, it increased another 2, 7 to 9. This table represents a linear function. Now let's do a harder example. What if you were given an equation that looks like this and asked, is it linear or nonlinear? Take z of x, for example. Whoa, what do? You want to manipulate the equation into slope-intercept form. Or you could just look at it and say, well, is there going to be a constant change between x and y? The latter will be harder. So let's manipulate it. Let's try to isolate y on one side. Using inverse operations, I can find this equation here. Rewriting it, I get y is equal to 9x minus 13. Notice this is a number next to x, 9x. This means it is linear. Linear. If this x had a squared on it, or you saw log, natural log, exponential, anything crazy like this, it would be nonlinear. All these examples may be confusing, or maybe not. Either way, ask your teacher if you have any questions or concerns.